Welcome to Spring LIB.
The first step to solving this problem is to figure out what the initial velocity is, given that the final velocity is 0 meters per second, and we're given the acceleration, and we're also given the time. So solving this for the initial velocity, we get that the initial velocity is equal to negative ax times t. Remember, we're setting vx to be 0. And then when we plug in that ax is 60 times g, and t is 36 milliseconds, which is also 0.036 seconds. And remember, g is negative 9.8 meters per second. So in total, we get that the initial velocity is 21.168 meters per second. Now that we have the initial velocity, we can use the kinematic equation x is equal to x naught plus v naught x times t plus 1/2 times ax t squared. And we're going to use this to solve for x, the total travel distance. Now remember, we can set x naught to be 0 for this. And this is just a choice that we choose. And so setting x naught to be 0, we plug in our initial velocities, our time, our a, and our time again. And this just becomes a calculator problem. So just to show you what we plug in, our initial velocity is 21.168 meters per second. We're going to multiply that by t, which is 0.036 seconds. Notice the seconds will cancel the seconds and we'll get meters, as we should, since we're calculating a distance. We're going to add that to 1/2 times negative 9.8 meters per second squared, which is our a here. And then we multiply that by the time squared, which is, again, 0.036 seconds. And then that's squared. And then just to check the units on this term, we're going to get second squared from this, which is going to cancel these second squares, and we're going to get meters, as we should. Now, what you'll eventually find is that x, if you plug this into your calculator, will give you positive 381 meters. And so you will travel 0.381 meters if you get in this accident. And that should be the final answer.